All right, Dorcas, here's the way it's going to work today. We're going to go over the warm-up. Tomorrow's the day. You've only worked an entire year for tomorrow, so there's that, right? So today we're going to kind of talk about strategies like unit by unit. I made, like this morning, I sat down and I kind of went unit by unit, made a strategy sheet. I'm going to bless you, share that with you. You can either take some of my strategies and write them down. Some of them you may choose to write, some of them you may choose to not write. But the nice thing about the strategy sheet is it gives you something to study. Andrew, thank you. It gives you something to study between now and tomorrow morning. Because what I don't want you doing is studying worksheets. Because at this point, you either have it or you don't. Now, if you wanted to go back and like say, okay, I just want to work one more systems problem, or I want to do whatever, then yeah, you can do that. But at the end of the day, guys, you're ready. You really are. I was tutoring a couple of Prosper kids yesterday at different times. I tutored an Allen kid, 2 Prosper kids, Frisco, and 1 McKinney from not our school. And both Prosper kids at different times told me it was impossible to write the equation of a line that was vertical. I said, you can't write the equation of a line that's vertical. And I went, what? Why do you think that? Because you can't put it in the calculator. Oh. Okay. So let's roll through this. Let's roll through the warm-up. Then let's start talking about kind of the strategy sheet. On the strategy sheet, I'm going to give you some ideas as to what you can do to it between now and tomorrow morning to make it more rememberable, if you will. So here we go. Students at a school will sell hats to raise money. There are some hats left over from last year, and 20 boxes of hats will be ordered this year. When the order arrives, the total number of hats the students can have can be determined by using the function. The minute you see this, put a little box around it because that's very important. Okay? It gives you the equation. You're good to go. Where X represents the number of boxes ordered. So all of a sudden, now we know what the variable stands for. Number of boxes ordered. Number of boxes ordered. If the number of hats per box changes so that the situation is modeled by this, then how many fewer hats will a student have available to sell if they still order 20 boxes? After all those words, what kind of a problem is this simply, Joey? You're just plugging it in. It gave you 20 boxes and 20 boxes here, and here basically it gave you the X value for 2 different equations. All you're doing is plugging it in. So you plug in 48 times 20 plus 37, and you get 997. Thank you, 997. And then you plug in on the h of x equation 24 times 20 plus 37, and you get 517, and then you simply subtract because it wants to know the difference. So, Sahidi, what'd you get? 40. Yeah, you're right, except that I would technically not get too technical, especially when you're just plugging in numbers. Why overthink it? Let's technically not mess something up that's already easy. By the way, what would this be considered, a 1, 2, or 3? 1. I would probably call it a 1. Thank you very much. You can set them right here. Thank you, thank you, thank you. It's like Christmas in July, except that it's not July, it's May. Okay? Her name's Huck. I had both her older siblings. Yeah, you had Drew and Lauren. Okay, here we go. The set of ordered pairs below represents some points on the graph of function f. What is the parent function of f? Basically, what are they asking you? How many different equations have we learned about? How many different types of equations? 3. 3, thanks to Unit 10. Right? We've had 3 types of equations. We've had linear, quadratic, and exponential. I know. Now, when you look at this, you have basically linear and quadratic represented, right? You have linear and quadratic. So how do you tell the difference in ordered pairs between linear and quadratic? And I'll accept 2 answers. Someone tell me how. Yes, ma'am. That's perfect. You can make a table of the x's and the y's, right? Now, when you do that, I would put the x's in order, okay? I would put the x's in order. So the first one is -7, -9. then we have negative 4, negative 3, then we have negative 1, 3, then 3, 11, right? And then 5, 15. And then, if it's linear, what should we see when we find change in y over change in x? A constant number. If the change in y over change in x each time is a constant number, then we have a line. So negative 7 and negative 4 is 3, that's 3, and that's 4. And then over here, that's 6, and that's 8, right? Change in y over change in x gives us a slope of 2 every single time. Therefore, it's linear. Therefore, it's that, automatically. If it wasn't linear, how could we have determined whether it was a quadratic or not? Riley? If you do the second, remember the second difference? Is that what you're saying? Okay, the second difference. If you do the second one and it's constant, then you're good to go. By the way, what's the other way you could have found out whether it was y equals x versus y equals x squared? You could have graphed it. You're given a coordinate grid paper on your test tomorrow. If you feel the need to graph them, okay? The only problem is when you graph a quadratic, so like say here's the quadratic, it looks like this. If the only points they gave you were from here to here, it could very well on a graph look linear when it's not. It could look linear when it's not, okay? But more than likely, they're not going to give you that. Any questions on that, guys? 1, 2, or 3 on this? I would have probably given it a 2 because it wasn't like instant. You actually had to kind of pause and think and find a strategy for solving. It wasn't, and that's why I want you to understand the difference. A number 2 question requires some degree of work. A number 1 question is literally look, know. You know what I'm saying? You look at it, you just know it. It's plugging it into the calculator, it's that kind of thing. The dishwasher at a restaurant is loaded with the same number of dishes every time. Blah, blah, blah. We're given a table. What should we probably do? Find the slope. Guys, if you're going to write an equation, it wants to know when the dishwasher is used 9 times. Okay? So at the end of the day, you're probably going to want to do this. Now when you, let's see, that's 2, that's 2, that's 2, that's 52, 52, 52. Change in y over change in x equals 26. 26 is our slope, right? Now, you need to find out if there's a y-intercept. That's very, very important. Does anybody know the fastest way to find out if there's a y-intercept, like a b value, when you write the equation? Tristan? You could. What you could also do, remember we talked about the fact that y equals mx plus b? Really quickly, just multiply everything times your slope. And what do you find? It's equal to your y value, which means there's no b value, right? So that means your equation is basically y equals 26x. Plug in 9 into x, and what do we get? 234. Any questions on that? Find the equation first. Always check for a y-intercept. Always check for a b value. Always, always, always check for a b value. Okay? This is the fastest way I know of to check for a b value. Once you find the slope, plug it into the, multiply it times your x and see if you get your y. If you don't get your y, you may have to add or subtract to get your y. Okay? And lastly, a painter charges $35 per hour for labor plus $40 for a ladder rental when he paints a house. What is that? What do we know right now about the equation? How do we write the equation? 35x or h plus 40, right? The total charge to paint his house was $950. What does $950 represent? Y value. Very good. So all we have now is we have $950 equals 35h plus 40. Straight algebra, yep. Subtract 40 from both sides. We have 910 equals 35h. That means h equals 26. Whoever said 25, check your math. Okay? Use the calculator. Any questions on this? You sure? All right, here we go. You need something to write with. You need a blank piece of paper. Then you just need to pay attention. Guys, here's what I want you to understand walking into tomorrow. You are freakishly ready to take this test, way more so than you think. Do y'all remember when you took the mock EOC, and all of a sudden y'all were like, really? You know, a lot of times y'all were literally like, I'm pretty good with this. I got this. And that was before we did Unit 9 or 10. That was before we learned officially how to solve a quadratic. It's before you knew about roots and zeros. It's before you knew about solutions. It's before you knew about the quadratic formula. It's before you knew about exponential functions. And you still did a really, really good job. All you have to do tomorrow is apply the strategies that we're about to talk about, and you're going to be good. All we're doing today is we're going to spend the next few minutes going unit by unit on things I think you should keep in mind. You're going to see the way that I built my sheet is a colorful way, and I'll tell you why. I have found that if you give a kid a blank, a piece of paper with just notes written on it and say, learn this, your mind gets bored. I mean, it's just a bunch of words. But if you make it graphic in nature, if you make it like a picture, your mind will recall it easier. And in fact, a lot of times whenever you're remembering something, when you're finding a memory, you usually find a memory based off of seeing a picture of what you did. It's almost like a snapshot or a video or whatever. It's because your brain remembers images easier than it remembers words. So let's talk about kind of the way that this looks. So in Unit 1, and I'm going to try to keep it separated, Unit 1. So Unit 1, for us, is exponents, like terms, radicals, and roots. Exponents, like terms, radicals, and roots. Now, if you don't feel that you have to write something down, I am perfectly cool with that. If you think of something that I don't know about, let me know. Now, I will tell you what I would do I would color it at the end. I wouldn't try to color as you go, because you may find as we're going through this that you remember something that you should have written down and didn't. I would write it all down first, and then I would go back and color. You can use one of those dry erase boards. Would that be helpful? So, Unit 1 is exponents, like terms, radicals, and roots. Some things to keep in mind. Flip negative exponents. The minute you see a variable that's raised to a negative exponent, remember I want that flipped. If you see something to a 0 power, get rid of it. Everything else is about like terms, and is it addition? Is it multiplication? What is it? Remember your powers rules. If y'all will remember on your formula chart, did anybody look at the formula chart and see that all the power rules are written on that thing? Did y'all see that? Okay. If you look at the powers are written on your formula sheet. They're written on your formula sheet. So when in doubt, look at the formula sheet, which you'll have. This is the only thing that I thought was worth mentioning again. Do you remember radicals going from simplified radical form to exponential form? Does anybody not remember that? Because if so, we can kind of talk about that really quickly. Basically, what it amounted to was that if you have like x to the 2/3 power, x to the 2/3 power, that was the same as the cubic root of x squared. Here, I'll give you another one. If you have, so I can write on this, if you have x to the 2/3 power, that is the same. The bottom guy goes out in front, and the top guy goes inside. These are the same things. We haven't done that in like forever. Remember that, though? Okay? And if you look at the example that I gave you here, the only thing being raised to the power is the xy squared. So that's the only thing that goes under the radical sign. And then the bottom guy goes outside, and the top guy was 1, so it didn't really matter. Got it? Yes, ice cream cone. Goodness sakes. Unit 2. Unit 2, there was a lot of stuff. Unit 2 is function, not a function. Domain and range, function notation. Those are the primary things in Unit 2. Function, not a function, domain and range, and function notation. For function, not a function, look at the x value only. Remember, they use that phrase, is y a function of x? That simply means, is it a function? Remember that the domain is your x values. Another way to think about that is it's the width of a function. When you're writing the domain, it's basically how wide a function is. When you're writing the range, it's basically how tall a function is. It's the y values. Be very careful on discrete versus continuous. Remember, continuous, you use the inequality signs. That's where the thing is connected. So this is a continuous function. A discrete function is dots. And you write the domain and range of a discrete function in brackets. You don't write inequalities. It's just the x values or just the y values. Obviously, when you substitute, when you substitute a number in for a variable, use parentheses. So like x squared is really like open parentheses, close parentheses, squared. And finally, for function notation, the question is, are they giving you the x or are they giving you the y? If it's inside parentheses, it's the x. If it's outside parentheses, it's the y. If they give you the x, they want you to find the y. And if they give you the y, they want you to find the x. Okay? That's function notation. Any questions on function notation? Unit 3 was a pretty brief unit. It was basically solving equations. The only things I can really think of to talk about is, do you remember when we gave you like an equation in fraction form, like x minus 1 over 3 equals 6 times x minus blah, 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 blah? Remember to cross multiply, and it'll get rid of the fraction part. Cross multiply equations that are written in fraction form, and then follow your equation rules. Remember, you get rid of parentheses first, then you combine same side like terms, then you move all your variables to one side, you move your numbers to the other, and then you divide to solve. Oh, remember when you're doing from words, that from or than are your flip words. When you're writing equations from words, from or than are your flip words. Also remember, is your equal word. Remember, if you see in a word problem the word is, that's equals. Is equals. And you're a third of the way through algebra now. Yay. Huh? I mean, on the cheat sheet. Yeah, we're rounding. Unit 4, our favorite of all units. Linear equations. Remember, slope is positive if it's increasing, it's negative if it's decreasing. If it is vertical, it is written in x equal terms. If it is horizontal, it is written in y equals terms. Unless you're from Prosper, and they can't write things that are in vertical. Yes? Oh, I'm sorry, yes. Is that okay? Remember, to find the perpendicular slope of a line, you flip it and change the sign. That was another thing that they totally disagreed with me about. They're like, no, Mr. Smith, if you have a positive slope of 5, then the perpendicular slope is negative 5. It's like, of course it is, because you know more than I do, being, in 8th grade. Don't even get me started. Flip it and change the sign. Remember the rules for standard form? Remember the rules for standard form? It's ax plus by equals c, and the a must be positive. That's one that kids just generally forget. The a value has to be positive. There also cannot be fractions or decimals. If you see the phrase line of best fit or correlation coefficient, they're doing that stat inner stat calc thing. Remember that? If they say line of best fit, or they use the word correlation coefficient, should I write that? Correlation coefficient, they basically mean the R values. Remember, if you have an R value of 1, it's basically linear data. If you have an R value that's way away from 1, like 0.2, it's just kind of scattered. Okay? Now remember how to turn on your diagnostics. Second 0. Go down to diagnostics, on, hit enter twice. The only time you need to do that is if it asks you for the R value. It's the only time you need to do that. Two last things. Point slope formula, which is also on your formula sheet. Remember, it's y minus y1 equals m times x minus x1. Right? So if you're plugging it in, I would do this and then plug in your x and your y. That way you can make sure you account for y minus a negative or x minus a negative or whatever. And you'll see it whenever you get on the test. It's not that difficult to do. Now, the only thing I did not put on here, but y'all have a great cheat sheet for it, is transformations. I might take a look at transformations for tomorrow morning. But most of y'all, actually, by the time we got through transformations, y'all were getting pretty good at transformations. Inside versus outside. Remember, insides are always horizontal and jacked up, weird. The outside ones are vertical and always normal. If you're adding or subtracting, you're shifting. If you're multiplying, you're stretching or compressing. And if you're making a negative, you're flipping or reflecting. Yeah, Unit 4 has got a lot of good stuff in there. Mm-hmm. You sure? It's good. It'll be fine. It just bounced y'all around a little bit. Unit 5. I will not, I'll leave Unit 4 up. Unit 5 is systems of linear equations. Elimination, substitution. Remember, you do elimination when the x's and the y's are all lined up? When the x's and the y's are all lined up? And your goal is to add them and make one go away. That's why they call it elimination. Be sure if you have to scale something, you multiply the whole thing by that number, right? Because that would end up being like 15x minus 6y equals 30. Make sure you scale the entire thing so when you add them up, either the x or the y goes away. Substitution is when one is in standard form and one is either x equal or y equal. And that's where you take this and plug it in for the x. Remember, if you have time to check your answers, you can simply plug in your xy answer into both equations and it should work, right? By the way, it's also a good way to just get an answer without really having to do any work. Remember, we had that warm-up on Friday where I said, which of the following is a solution to the system? You didn't really have to solve the system. You just had to plug in the x and y into both equations and see which one works. This is the one I really wanted to point out. Remember the trick. Remember when we did quarters and nickels and stuff? You're supposed to write 0.25Q plus 0.10D, right? For dimes and quarters and all that stuff. Remember what they like to do to try to trick you. They would write 0.25D plus 0.10Q. They would mix, they would not match up the right number with the right variable. They love doing that kind of stuff. They love doing that kind of stuff. Oh, and by the way, this is correct, yeah? Is this correct? Yes, it is. I scaled it by 100. I didn't change it. I just multiplied everything by 100. It's the same equation. Remember, as long as you multiply everything in the equation by the same number, it's the same. So don't think this would be wrong. It wouldn't be. Okay? So something to think about. Any questions on units through 5? Can we slow down, Avery? Okay. Avery. Are you done with 4? You done with unit 4? Okay, come on now. Unit 6 is inequalities. And I'll put this back up at the end. Unit 6 is inequalities. It was not a really difficult thing. I will show you kind of how I wrote this. Remember that greater than, first of all, you always want to put it first into slope-intercept form. Remember, you want to get the y by itself and then the mx plus b on the right so that you can graph it. You have to be able to graph the linear inequality using the slope and the y-intercept. Always start at the y-intercept and use the slope. Then you have to think, is the line dashed or solid, and do I shade above or below? If it's greater than or equal to, you shade above. If it's less than or equal to, you shade below. If it's this, it's a solid line, and if it's this, it's a dashed line. Those are kind of your questions on a linear inequality. Can you see okay, Brady? Okay. The only other things I put is, remember when you're solving, if you have to divide by a negative, you have to flip the inequality sign. If you ever divide by a negative, flip that inequality sign. That will guaranteed be on there at least once, probably twice, where when you're solving, you have to divide by a negative. The only other thing I put on there, remember the or and the and, guys? Where it was like x is greater than -2 or x is blah, blah, blah. Remember the or guys go out like a boat. Remember the and guys come in. I will have these online scanned in color as a PDF file, so you can actually go home and pull this up in the EOC readiness folder. I think I'm going to call it like final note sheet or something. So, I mean, in other words, you're writing it down. I think that's great because you're more likely to remember it if you've written it down. But if you get home tonight, you want to adjust yours or just look over, you're welcome to pull mine up. You can even pull it up on your phone pretty easily. All right. Last unit on this page is Unit 7. There wasn't a lot to Unit 7. It was where we learned about quadratics, the vertex, the axis of symmetry, the domain, the range. Remember, you have to find that vertex using that vertex formula. It's on your formula sheet at the bottom of the page. It's called axis of symmetry, and it says axis of symmetry equals negative b over 2 times a. So you don't have to memorize it. You just need to know where it is. Once you find the vertex, remember the range is based off the y value of the vertex, and the axis of symmetry is based off the x value. So that you have to look at the quadratic and know whether it faces up or faces down, right? But y'all can do that based off positive or negative. What's the fastest and easiest way to find the vertex? The calculator. Punch into the calculator, look at the table, find symmetry, be done. By the way, what's the fastest and easiest way to find the solutions to a quadratic? Calculator as well. Look for where the y value is 0. Three more peeps. About another minute. And like I said, I'll put these back up on the board here in just a second, okay? Unit 8. Unit 8 was multiplying and factoring quadratics. Now, this is the one that scares the crud out of me. Remember when you're factoring a quadratic, you have to find the number that when you multiply two numbers, you get a times c, and you add, you get the b value. Please watch the value of b. If the b is negative, make sure that the numbers you chose add up to a negative number, right? You have to be careful about that. So in other words, if you have like x squared minus 3x minus 10 equals 0, your factors have to be x minus 5x plus 3. So that when they add the negative 5x and the plus 3x, you get the negative, wait. Oh, two. God, that was terrible. There. Remember, you know what I'm talking about? Be careful on that b value. That's the one that always kills me. And remember, you can use the box, you can use the FOIL, or you can use double distributive to factor. No problem. When you multiply, I would use the box methods. You can use FOIL also, but you know. Always check with a calculator. Always, always, always. A lot of times on an on-level algebra test, they're going to have you find the solutions to a quadratic that you can just find in the calculator without really working. By the way, what would the solutions to this quadratic be? What would the solutions be? What would the roots be? What would positive 5, negative 2? Remember, you set those equal to 0. There's a difference between the factors and the solutions. The factors help you find the solutions. They're not the same. These, guys, these are the factors of the quadratic. The solutions are then making them equal to 0, which gets us to Unit 9, which is where we solve quadratics. Roots, zeros, solutions, x-intercepts, they all mean the same things. This is a big deal. Watch for excluded answers. What I mean by that is, remember when it was a measurement, what could you not have? Negative numbers. So even if you get two answers, a negative and a positive, you have to get rid of the negative number. You can't have a negative measurement. So watch for excluded answers, and that usually means negatives. Remember what the discriminant is? It's b squared minus 4ac. Remember that b squared minus 4ac, if it's greater than 0, you've got 2 roots. If it equals 0, you have 1 root. And if it's negative, you have no roots, no solutions. And at the end of the day, guys, if you run into problems, remember the quadratic formula, even though it looks ugly, it always works, no matter what. You just have to put it in standard form and make it equal to 0 first. That is critically important, making the quadratic equal to 0 first. That's putting it in standard form. And your last unit, which is the one we just finished, is pretty much this. Exponential functions. Remember the growth or decay model is your starting point times 1 plus or minus the rate to the x power. X being time. This is your time intervals. This is the starting point. Remember, if you double something, the rate is 1. If you triple something, the rate is 2. And then we did geometric sequencing, and this is the formula. I'll tell you what I would do. That'd be the last thing I looked at before they gave out the test. And the minute they handed out the test and told you to break the seal and said start, I'd write that on your formula sheet, both of them, as quickly as you can remember them. You know what I'm saying? If you're worried about either one of those formulas, I'd stare at them right before they pass out the test. And then the minute they passed out the test, I'd write it down. You can do that because you didn't cheat. You brought it in your brain. Okay? Any questions on that, peeps? Oh, I'm sorry. I went too far. My bad. And the last is this while you finish writing. Write down your formulas first, what I just said. When in doubt, make an XY table. Or plug in your X and your Y and see if it works for what you're trying to find an answer for. Remember, I want you guys rating those questions 1, 2, or 3, and do not start a number 3 question. If you think it's hard, if you're unsure about it, skip it. It is not going to leave the page. It is not going to run away. You can come back to it later. A lot of times you'll find, I think y'all have done this before, where as you go through a test, you all of a sudden, at another question, realize, oh crap, that's what they meant. And you can go back to the problem and knock it out then. Use eliminating bad answer choices as a good strategy on this algebra EOC. If you do, you'll be great. You'll find that some answers are absurd. Even when you don't understand how to answer a question, you'll be able to eliminate a couple of answer choices, which boosts your opportunity for guessing in a much better place. Check using the y equal in your calculator, and remember to turn on your diagnostics using second zero. Other than that, guys, that's it. I'm excited. I really am. And I'll say that because y'all will not know how ready you are for this test until you start reading the test tomorrow. You're way more ready than you may even think you are. I don't want you winding yourselves up into a frenzy tonight. I don't want you worrying. I don't want you going home and doing worksheets. It's the last thing I want you to do. Use this little cheat sheet you just made and look at this between now and tomorrow morning. When you go into your classroom that you're taking the test in, walk in, sit down, and look at it. It'll help you remind yourself. And then just knock this out of the park. Yes, ma'am. Y'all will be there through 5th period. You'll only go to 6th and 7th periods tomorrow. You will only go to 6th and 7th periods tomorrow. Does anybody not know where to go tomorrow? Okay, hold. Test. Did I still tell y'all to go to Miss Wilson's art room? Yeah. Okay, so 8th graders, you're going to Miss Wilson's art room. 7th graders, you're coming to me. Okay. And the room will look just like this, those of you that are in my room, except I will have half the lights on, and I will be covering up the XY in the back. Okay? Yes. Oh, if it says something is doubling every year, then your rate of change is 1. I'm talking about the rate. The rate is, remember that? Yeah. Tripling is a rate of change of 2. Okay? All right? Y'all are way ready for this. Everybody good? Any last questions? Good. Chill. Let me do. Yes. Why? There's both of them, by the way, if y'all want to see both of them. You're welcome to get up and look and do whatever. Yes, you may. And like I said, I will put this on the website.